I am Anil Kumar. Welcome to my playlist on probability and expected value. We'll consider two events A and B and figure out how does it make a difference if they are dependent events or if they are independent events. The example taken here will make you understand the basic difference and therefore will be very helpful in moving forward with a very clear concept. The question here is: consider two events A and B where probability of A is 0.58, probability of B is 0.32. Calculate the following for different cases. A. Probability of A when B has occurred, it's a conditional probability, is 0.2, and A and B are not independent events. In that case, calculate probability of A intersection B and also calculate probability of A union B. Second case is A and B are independent events, and in that case, calculate probability of A intersection B and probability of A union B. So, for two different conditions, one when these events are independent, and the other when they are not independent, means dependent, you need to calculate same figures, intersection and union of probabilities for both the events. Perfect. I am Anil Kumar, and in case you want to learn directly from me, feel free to send an email on globalmathinstitute at gmail.com. Our students are right there on the top, getting admission to the best universities. Little bit of guidance make huge difference. Okay, so now let's consider the solution of the problem at hand. So we are given two events A and B, and we are given their probability. So let's write down what is given to us. Probability of A being 0.58 and that of B is equal to 0.32. For part A, we are given that the probability of A when B has occurred is equal to 0.2. Right. Now, under these circumstances, we need to find probability of A intersection B, right? Let's calculate the probability of A intersection B. We are given that this is not an independent event. That means it is a dependent event, right? So now we can find the probability of A intersection B as equal to. Now, since B has occurred, we need to multiply with probability of B the probability of A when B has occurred. You get the whole idea. So that is the intersection. So B has occurred, so find the probability of B. And now, what is the probability of A? So that should be equal to probability of B being 0.32. And we need to multiply by what is given to us, 0.2, which gives us 0.064. Make sense? So that is how you're going to find the probability of A intersection B. And now let's find out in part A, we're talking about dependent events, right? What is the probability of A union B? So probability of A union B is probability of A plus probability of B minus intersection or probability of A B. So that gives you probability of A is given to us as 0.58 plus 0.32 minus 0.2. Correct? So that should give you the right answer. So you can now calculate this value and write down your answer. Right? It is 7 over 10 or zero point 0.7. Correct? So zero point 0.2 taken away 0.58 will be 0.38, and when you multiply add 38 and 32 you get 0.7. So that is how you do part A, which is a dependent event. Now let's do the independent event, part B. So in part B, we are given independent events. Now, in case of independent events, probability of A intersection B should be equal to probability of A times probability of B, correct? And that is just multiply the given probabilities, which are right there for us. So probability of A is 0.58, and we're going to multiply this by 0.32. You can use the calculator. 0.58 times 0.32, and it gives you in decimals equal to 0.1856. So that becomes the probability of A intersection B, right? You see, it is very different from what we got earlier, right? Now, let's find the probability of A union B. So, probability of A union B will be probability of A plus probability of B minus probability of A intersection B. So, that is equal to 0.58 plus 0.32 minus 0.1856. And now we can calculate this. 0.58 plus 0.32 minus 0.1856. So that gives you 0.7144. You can say approximately 0.7. Correct? So that is how we'll find the probability of A union B. You see, for two cases, it becomes absolutely different. And I hope with this example, you understand the concept of independent and dependent events also. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.